So what I'm going to do today is just going to take a look, or in this lesson here, is just take a quick look at what happens if our points aren't exact, okay? And there might be, may not be. Now, let's just say that we're given some group of data. So maybe you've gone out and you've taken some exact data or something, and you want to try to match it with an equation. Now, the equations that you could match it with, there's a whole bunch. You could do, is it a straight line? Is it a quadratic? Is it a sinusoidal graph, which we'll take next year? As well as there's some other ones that you look at next year, which are a lot of fun, cubics and so on and so forth. But we kind of try to see what does it look like, and then we try to match it with that graph. Now, I've put in 5 points here. They're random points, just kind of threw them together. And they make it look like it's a bit of a V, maybe a U shape. So we're going to assume that this is probably a quadratic, or we're going to try to come up with an equation which represents these points as close as possible. Now, what Desmos will always do is it'll draw its line of best fit, which is going to be a exact either quadratic or linear function or so on and so forth, which represents the dots that are given or the points that are given. So these 5 points we're going to try to draw a line of best fit through there. So if I was doing that here, mine would look like, I'm not going to do a very good job of this, but something like that. Ah, it's not really that great, but I tried. Um, so this is kind of what I'm assuming it's going to look like based on the points I see. So I'm just going to erase that. I'm going to let Desmos do its magic. So I've already typed it in. I'm just going to I'm not showing it right now. There we go. And bring it back. Okay, so if I plug in the regression, this is what comes up. You'll notice that it's a perfect U shape. Okay, it's a perfect parabola, and it doesn't hit every single point. Some are right on the line, some are a little bit off. What Desmos is doing is it's trying to approximate roughly a quadratic equation. So it's not going to be through all the points because that just wouldn't work. Okay, it's trying to draw a line of best fit through the points as best as possible. Okay, as best as possible. And this is what it comes up with. Now you notice that this point's really close. That point looks like it's on the line, but these other three are just slightly off. Okay, so it's trying to kind of come up with a quadratic that looks somewhat right. Now, I'm going to show you another one here. Okay, I have another few points here, and these are actual real points on the heights of males at age 3, 7, 10, and 18. Okay, this is the average height. This is actually taken from growth charts for Canada, so it is actual data here. Now, if we look at these points here, what do they look like? Does it look like a straight line? It kind of does. And we can try to approximate using Desmos a straight line using graphic form, which we took a look at last unit in linear inequalities as well as last year in linear equations. And so if you plug that one in, you'll notice that Desmos kind of tries to give us a line that roughly goes through all those values as close as possible. Now they're all a little bit off, but not a lot. Okay, it kind of shows that maybe the heights of boys is somewhat linear. Okay, somewhat linear. It shows roughly a linear pattern. Okay, it shows roughly a linear pattern. Now, is it exactly linear? No. Can we maybe try a quadratic in there? Okay, so I'm going to turn off the linear one and I'm going to put a quadratic. Let's see if it looks like a quadratic. And if you notice, these points really do line up very nicely on a quadratic. So maybe the height of boys, okay, at least in these ages that I've given here, somewhat represents a quadratic equation, okay, with A's, B's, and C's as given here. Now you'll notice if we zoom out, it's not exact because it says that males can grow until they're about 44 years old. I'm using age and height there, and they'll get to be quite tall. That's not exact. 18 is about where they plateau, in fact. But this gives us an idea of what maybe we should look at if we project certain values or if we project certain values. Now, again, we could use the linear one, and you'll notice the linear one goes through pretty close. Okay, it's pretty close to linear, but maybe quadratic will be a little bit better as we project into that. So that's how we can use a regression. This is the regression for a linear equation, okay, mx plus b. Okay, I use y1 and x1 for that, and you'll learn how to do different regressions as well for different equations as we go through, or as you go through, especially next year, and what that looks like.